Welcome to Fascinating Frontiers, episode 133. Today is July 16th, 2026. Let's look at what's new across the frontiers of space and science. Astronomers have directly imaged a third giant planet in the Beta Pictoris system by spotting its carbon monoxide signature with JWST. JWST captured the new world designated Beta Pic D, while observers were studying the atmosphere of the known planet Beta Pic B. An unexpected blob appeared with the clear spectral signature of carbon monoxide. Its motion, location, and alignment with the star's debris disk confirmed it as a bound planet rather than a background object. Researchers will now use additional Webb data to refine the object's temperature, atmospheric makeup, and orbital parameters. The bright debris disk had previously scattered light and hidden such companions from earlier telescopes. Follow-up observations are already scheduled to tighten the orbit solution. This marks the third directly imaged planet in the system and adds a new data point to studies of giant planet formation around young stars. JWST's ability to ignore the bright debris disk and isolate the planet's carbon monoxide signature made the find possible after earlier telescopes had missed it. Refined temperature and orbit measurements expected from upcoming observations will test whether the planet formed in place or migrated. How many more hidden worlds remain undetected in other bright disks? If the Sun were replaced by a typical young star still surrounded by its birth disk, the nearest planet-forming zone would sit inside a glowing ring of dust and gas, no wider than the orbit of Jupiter, yet containing enough material to build several Earths. Inside that ring, micron-sized grains collide and stick, growing into planetesimals while the leftover dust scatters starlight into a bright haze that can outshine any embedded world by factors of thousands. Telescopes on the ground must therefore block the star's glare with coronagraphs and subtract the disk's speckled light in software. Even then, a forming planet only becomes visible once it clears a gap or heats a local patch of gas enough to produce a distinct spectral line such as carbon monoxide. The Beta Pictoris system shows this process in action because its disk is so luminous that earlier instruments could not separate the new planet's signal until JWST observed at mid-infrared wavelengths where the dust is fainter. The remaining puzzle is why some disks reveal their planets quickly while others stay opaque for millions of years. What sets the clearing timescale that decides whether we ever get to watch a giant planet grow? NASA will stream live from the clean room where the Dragonfly rotorcraft is being assembled for its mission to Saturn's moon Titan. The event is set for 2 p.m. Eastern Time on the agency's Twitch channel. Dragonfly will use 8 rotors to fly between multiple sites on Titan, sampling surface materials and measuring atmospheric properties. The preview offers the first public look at the flight vehicle in its final assembly configuration. This update shows hardware integration progress on an outer planet mission. The Flex fluorescence mapper and Copernicus Sentinel-3C ocean and land satellite have arrived at Europe's spaceport ahead of a September launch on Vega C. Teams will spend the coming weeks performing inspections and integrating the spacecraft with their rocket. Both missions will deliver new Earth observation data once in orbit. The satellites represent complementary capabilities, with Flex focused on vegetation fluorescence and Sentinel-3C extending ocean and land monitoring records. After more than a decade of targeted searches, astronomers recorded the dimmest planet ever directly imaged from the ground. The object appeared as a faint moving spot in repeated high-contrast observations. Its extreme faintness required long integration times and advanced adaptive optics techniques to separate it from the host star's glare. Further measurements will determine its mass and orbital distance. Scots astronomers contributed to the discovery of this faint exoplanet in a distant system. A new study shows that current ground-based methods cannot yet determine how fast supermassive black holes are rotating. The authors demonstrate that a future space-based X-ray observatory could measure the spin by tracking iron line profiles close to the event horizon. The work highlights the need for stable, high-resolution spectroscopy above the atmosphere, Determining spin rates is described as key to understanding how black holes affect their immediate vicinity and the galaxies that surround them. SpaceX plans a suborbital Starship Super Heavy flight that will deploy the initial Starlink V3 satellites while testing hardware upgrades aimed at full reusability. Liftoff from Starbase, Texas is targeted inside a 90-minute window opening at 5:45 p.m. Central Daylight Time. The mission will provide an early look at the larger, higher-capacity Starlink design. This step advances testing of orbital refueling prerequisites and rapid reuse cadence on a flight that also carries operational payloads. A Falcon 9 will carry 21 satellites for the Space Development Agency's Tranche 1 transporter layer from Vandenberg Space Force Base. The satellites form the third operational batch supporting the proliferated warfighter space architecture. Launch is scheduled for 1:32 p.m. Pacific Daylight Time. The mission continues the commercial spaceflight emphasis on constellation deployment cadence and cost reduction. New models show that galactic spiral arms and central bars act as efficient pumps that move gas inward, fueling the high star formation rates observed during cosmic noon. The structures create shocks and torques that concentrate molecular clouds on timescales of a few 100 million years. The findings help explain why star formation activity peaked between 2 and 3 billion years after the Big Bang. Peak rates during that era reached up to 100 times the present-day value. NASA continues to integrate SLS and Orion components while running launch day scenarios inside mission control for the 2027 crewed lunar landing. The agency reports steady progress on both the lander and gateway elements needed for the mission. These steps address the remaining schedule questions for returning astronauts to the Moon's surface. This update moves the Artemis and the Moon program forward by demonstrating concrete hardware assembly and operational rehearsal progress toward the crewed landing schedule. The rover photographed an unusual honeycomb-like texture on a rock surface inside Gale Crater. The pattern's origin remains unclear, with possible explanations ranging from mineral precipitation to wind erosion. Mission scientists are examining additional images to determine whether the feature is widespread or isolated. The observation adds to the robotic exploration record of surface processes in Gale Crater. The Dale Reed Subscale Flight Research Laboratory at Armstrong Flight Research Center flies small, remotely piloted aircraft to evaluate new aerospace concepts at low cost. These vehicles allow engineers to mature technologies and reduce risk before full-scale development. Recent flights have focused on autonomy and novel wing designs. The approach supports NASA's broader goal of accelerating flight innovation through repeated, inexpensive testing. A robotic servicing spacecraft is completing in-orbit checks before raising NASA's Neil Gehrels Swift Observatory to a higher altitude. The mission will extend the satellite's operational life by moving it out of residual atmosphere. Teams report that commissioning activities are proceeding on schedule. The altitude raise will reduce drag and allow continued multi-wavelength observations of transient events. Rocket Lab completed a full-duration static fire test of the Archimedes engine that will power the second stage of its upcoming Neutron launch vehicle. The test demonstrated stable combustion and throttling across the required duration. Data from the firing will support final design validation for the medium-lift rocket. The engine is intended to enable Neutron's role in commercial and government launch markets. A broken circuit breaker switch and the felt tip pen used to activate it during Apollo 11 sold together for $860,000. The items illustrate the improvised solution that allowed the lunar module to lift off from the Moon. The sale underscores continuing public interest in the mission's hardware. The pen was used to close the circuit after the original switch failed. Plumes from Ontario fires drifted southeastward, crossing Quebec and reaching parts of the U.S. Midwest and Northeast. Satellite imagery tracked the smoke's path and aerosol loading over several days. The event provides fresh data on how boreal fire emissions affect regional air quality. NASA Earth-observing instruments captured the movement of the smoke across international boundaries. Next time, keep an eye on the first public views of Dragonfly in its flight-ready configuration and the upcoming Vega C launch window. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow, and if you'd rather watch than listen, find us on YouTube at Nara Network. Links in the show notes. And before you go, this show is part of the Nara Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. The Do Positive Pod, good news in science and tech, plus one concrete action you can take. Find every show free at naranetwork.com. Following the long arcs, story trackers on naranetwork.com follow major programs across episodes. Tesla, SpaceX, AI, space science, and more. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.